Welcome back! We've looked at superposition and interference. Today, we combine multiple qubits to build real entanglement through code. We're talking about the CNOT gate and creating Bell states using Qiskit.
In classical computing, gates usually take one input. But the controlled not CNOT gate takes two qubits, a control qubit and a target qubit. If the control qubit is 1, it flips the target qubit. If the control is 0, it does nothing. In Qiskit, you write this simply as Qseed CX0, 1. Here, qubit 0 controls qubit 1.
By combining a Hadamard gate and a CNOT gate, we create a Bell state and entangled pair, where measuring one instantly determines the state of the other. The code is short.
When you run this, you will never get a random mix like 01 or 10. You will only ever measure 00 or 11. Perfect correlation.
The CNOT gate links qubits together, and pairing it with the Hadamard creates an entangled Bell state. In our final intermediate video, part 5, we'll look at putting everything together into a real quantum algorithm, Deutsch's algorithm.
Think of the CNOT gate as a conditional relationship. It doesn't just change data, it builds a relationship between qubits. This foundational pairing is what allows quantum computers to perform multi-qubit parallel operations.